Yeah, hi, good evening, good afternoon, everyone, and welcome to the session number 1A. The chair for this technical session number 1A is Dr. Uki, who is from Botswana, and I think he has some network issues, so he'll be joining in next 5 minutes. But I'll be starting this session as a chair. So I think everyone know how we are going ahead with that. So every presenter will have 12 minutes for the presentation and then next 3 minutes for the question answer from the chair as well as from the audience. So we at Global Knowledge Research Foundation have been pioneering in doing activities across the globe in last many years, and we appreciate your gesture to be a part of SMARTCOM 2021. And again, being an author is a long process, submitting a paper, then getting it reviewed by the organizers, and then you have to wait for the comments, and then after the comments the decision of the paper, and then you have to again revise the paper according to the comments and then resend. So it's a long process of, let's say, 4 to 5 months, and I appreciate the gesture for everyone to be a part of such kind of thing. Anyways, but every effort creates a difference. So I appreciate all the gestures made by all of you and starts with the session number 1A. So for this session, we have the first presenter, uh, or the first paper, induction motor overload recognition based on sound analysis. And paper presenter is Professor Fong. So Professor, you are here? Yeah, over to you.
I'm
You
here.
can start sharing your screen. Yeah.
Yeah. So can you hear me?
Yes, I can hear you.
Okay, thank you. I'm going to share my screen. Give me 1 minute. So can you see my screen?
Yeah, yeah, Professor. You can go
Okay,
ahead.
thank you. Okay.
You have 12 minutes, and after that 12 minutes, you will get a remainder, and next 3 minutes for question answer. Thank you.
Okay, so good morning, good afternoon, and good evening. My name is Nguyễn Công Phương. I'm from School of Electrical Engineering, Hà Nội University of Science and Technology, Vietnam. So today I'm going to present our research. It is the induction motor overload recognition based on sound analysis. So induction motors are very popular. We can find them everywhere in life, in industry, in factories. And that's why conditioning monitoring is something very important. The problem is that they do have faults. Faults of induction motors can be classified into bearing, stator, rotor, and other things such as eccentricity. So in order to detect the fault of induction motors, we can use this kind of signals. The first one is because induction motors is an electric device, so we can use electrical signals such as the current, voltage, magnetic flux. And besides, we can use mechanical signals such as vibration or noise. And we can also use thermal signals or chemical signals. So our research here is to detect the overloads. The overload here is defined as 110% and 200% of full loads, and we use sound analysis to detect this. So the advantages of our approach is that, firstly, normally sounds of overloads they appear earlier than the consequences, such as too high temperature or tooth breakage. So detecting an abnormal sound, it can prevent these consequences from happening. A second advantage, I think, is that the sound sensor is actually a microphone, so its installation maintenance are very expensive, like other sensors such as the current sensor. And the next thing is that our algorithm here, our approach here, does not need to stop the the motor during the detection, so we can apply some kind of say real-time or online detection. So in order to study this problem, we try to collect a database corpus. So you can see here, our we put the microphone close to the motor, and we connect the microphone to electrode. So this is our sound acquisition system. And I showed you here the spectrograms of the normal sound here, 110% here, and 200% here. You can see that we can see some differences here. Like firstly, the similarity here is that the power distributed from about 0 to 8,000 hertz, but the main power is how can I say, is concentrated on the first figure here, and for a very too high overload sound here, you can see that the power is distributed over other bandwidth such as 1,000 or even 7,000. So totally, we collected 137 seconds of this one, 131 of 110%, and 112 seconds of 200%. This corpus is used for our further experiments. So actually, our approach here is to design a classifier. So for classifier, we have to do mainly two things. The first one is to find a discriminant feature set. So in our research, we use the first frequency components, the MFCC, and the band energy ratio. They set up a set of 70 features. So in order to try to reduce the number of features, we put them into a PCA, principal component analysis, in order to reduce the number of features. And the output of this one will be put into a classification model. And we tested here 6 models, as you can see here. The first one is ANN, and then DT, FIH, GMM, KNN, and SPM. So in the first phase, we try to classify our frame of 1,020 samples per frame. And we increase the number of features from 1 to 17. And as you can see here, when the number of features is 1, then I'm sorry, I want to mention that this axis is the number of features. And the vertical axis here is the accuracy rates. Of course, the higher the accuracy rate, the better the system. So when the number of features is very small, say 1, then you can see that the accuracy rate is not very good. This one is about 55, this one is 65. And when we increase the number of features, the performances of these models are improved significantly, I think, like this. For example, for ANN here, when the number of features is 17, then the accuracy rate is about nearly 80. And you can see the zoom in here. We notice some spacing problem. It is that the greatest number of features is 17. It is not good for every model. For example, for GMM here, when the number of features is 17, the maximum here, then we have a drop at this position. So finally, by observing these graphs, we can find the best number of features for each model, as you can see here. And we also see here, we also present here the corresponding accuracy rate of each model. And because we do this with the 10-fold cross validation, so we can also collect the standard deviation. And if you look at this, you can see that except SVM, the 5 other models are very stable because the standard deviation through the 10-fold cross validation is very small. And of course, SVM here is not very stable because you can see that the standard deviation here is more than 12%. So in the best case, you can see that this one is not so good. The maximum here is only 77. So in order to improve this, we try to move to the second phase. It is to classify segments of 1 second. The duration of each segment is 1 second. So in this case, in this problem, we apply the rule, say the Wiener tone. For example, 1 second of signal, it consists of 86 frames. And for example, if of these 86 frames, there are 40 frames of 100%, 30 frames of 110 and 16 frames of 200. Then because this number is the maximum, so the whole segment of 1 second here will be assigned to the 100% class. So if we do by this way, we can summarize here the corresponding confusion matrices of each model. The first thing you can see, the first thing we notice here is that the diagonal elements here are they are pretty large compared to other off diagonal elements. And among this model, SVM is not the good one, the best one, I'm sorry, because you can see that this off diagonal element here is very big. On the other hand, I think that DT here, the decision tree here is the best because the off diagonal, the only one non-zero off diagonal is just this, and it is only one. So in order to improve the performance here, we try to classify 0.2 segments, and we tested this one with only the decision tree. And if you look at this, you can see that among these, we can obtain the best performance with this one, 15 features compared to the 13 features before. And for that one, you can see the distribution of segments here is like this. But if you compare this one, the 0.5 second classification to 1 second classification, you can see that this one, the best for the right, and this one, the best for the left, is nearly the same because when you increase the resolution, say that, then we also increase the error rates. So this one and this one, they are similar by the point of view of performance. But because this one corresponds to only 13 features, this one is 15. So less features means a simpler system. So finally, we choose this one as our classifier. So finally, this is our approach. We use a set of discriminant feature consisting of S0, MSCC, and BER. We put this one into the PCA to obtain a set of 13 features. And this set is put into this ANN, and the whole process here, it takes only 1 second, 0.15 seconds to process 1 second of signal. And our approach here can come to the root of some problems such as tooth breakage, various roller bearings and gears, and excessive temperature, or even the bending motors. So we understand this one is mainly on the sound analysis. So if we move this application to a factory, for example, then we have to apply some filtering techniques to remove any unexpected noise. Thank you.
Thank you, Dr. Fong. And I think any questions from the audience? Any questions from the audience? I think the session chair, Dr. Uki, is also here now. So, Dr. Uki, do you have any questions? So, Dr. Uki is the session chair for the session, and he is already here. So, Dr. Uki, are you able to listen to me? Do you have any questions? Okay. No worries. I think Professor Fong, it was a nice presentation, and so as the audience do not have any questions, so thank you very much for your presentation, and we just left you out, so I'll ask my team to flash your picture as well.
Okay, thank you.
First presenter picture. Yeah, this is for you to have a snap of your good self. Right. So thank you very much. Thank you.
Thank you very much.
Just to introduce, thank you. So just to introduce Dr. Uki, so Dr. Uki is a professor at University of Botswana, and he is expert. He is an expert in measuring quality in software systems. He's working on software software architecture, information system analysis and design, information system security, then machine learning, information, e-government, data mining. He has various post-graduation supervision area also, and he has many students who is working under his guidance throughout the. And he has more than 20 publications to his credit as well. So, Dr. Oki, would you like to say any opening remarks for this session, or should we continue directly?
Hello, can you hear me?
Yes, yes, Dr. Oki, we can hear you.
Okay, just to add that I'm also a senior member of the IEEE, and
Yeah.
we have worked together for some time, and I hope that this conference will bring some more eye-opening into our research areas as we listen to the various presenters. So we can go to the next presenter.
Yeah.
Multiple sequence alignment algorithm in bioinformatics.
From Bharat Reddy. So is
Bharat
Bharat here?
ready?
Yes.
Yeah, you can share your screen now.
Okay, just give me a
Okay.
second.
So again, you have 12 minutes for the
Hello.
presentation and 3 minutes for question answer.
Oh,
Bharat, you have
Jesus.
12 minutes for the presentation and 3 minutes for question answer, right?
Okay, just give me a second, sir.
Go ahead, please.
Where is the share screen? Okay. Guys, are you able to see my screen?
Yes, we can. You can just make it a, yeah, now it's perfect. Perfect.
Okay, all right. So good morning, good evening, good afternoon, or wherever you are. So my name is Bharat Reddy, and today I'm going to talk about multiple sequence alignment algorithms. My area of expertise is on bioinformatics, artificial intelligence, and reader-writer lock synchronizations, on which I have published some papers. We are moving away from pairwise sequence alignment, which has been our previous area of research, into multiple sequence alignment algorithms today. So that has been the motivation of this presentation and this paper. So the agenda that I have today is we're going to talk about what is a multiple sequence alignment, what is the computational complexity on this, progressive alignments, what are those, what are the iterative alignments, genetic algorithms, and conclusion as to where we stand today and where we want to go in the future. So, so a sequence alignment, by which is a way of arranging sequences of DNA, RNA, and proteins with an objective to find regions of similarity. And by regions of similarity, we mean this could be of a figuring out genes, evolutionary functions, and other informations. There are two types of sequences. There are multiple and pairwise sequences. Like I said before, my previous research was on pairwise sequence alignment. So this paper is going to talk about only multiple sequence alignment algorithms. So when two sequences are aligned, there might be some places where the characters are not aligned. We call them as indel deletions. If you want to take into the perspective of the first sequence, or you can see it as an insertion from the second sequence point of view. When there is a match between the two sequences, we obviously call it as a match, and there are some cases where there could be a mismatch, as you can see between the C and G here. Pairwise sequence alignment can be classified into local and global. So the local sequence alignments finds regions of, there are sub-regions, and they don't find the regions of similarity between the whole length of the sequences. So the local sequence, like the name says, only finds the sub-regions, and that's why it is called local sequence alignment algorithms. And there are many famous ones. That's BLAST, BLAT, BLATZ, and there are so many others. Global sequence alignments find the best match in the entirety of the sequences. And there are some dynamic programs here, like starting from Needle-Wolfman's all the way to Lagan, which is like the most modern ones. So where were we? So we are, like I said, in a zone where we are trying to align more than two. So which brings this paper, which brings this presentation. So when you are aligning more than two sequences, then it is called multiple sequence alignment. Is used in sequence homology and phylogenetic evolutionary relationship analysis. Because it involves more than two, and normally um, it involves more than five, usually that is the case. And this could go on since one of the reasons that you got to um, think is the length of the sequences are not like um, 100,000 characters in length. They go all the way to billions of characters in length. So that brings in complexity. That brings in complexity to hold, and that brings in a challenge to search. So there are different data algorithms, there are different data structures uh, trying to hold it. On the other side, there are also some hardware which are designed only for these multiple sequence alignment algorithms. So it is so hence it is very computationally complex because it involves more than two. Even otherwise, if it were to be only two sequences, it's still computationally complex. So we cannot use dynamic programming. Dynamic programming is a very slow approach, but it's very sensitive. But hence we come up with the heuristic algorithms, which are used to overcome the shortcomings of the optimal algorithms. Like I said, it's a dynamic programming algorithms. And some of the famous ones that we have, and some of the famous ones that we currently use in, let's say, the Europeans and the Americans, the cluster W, T coffee, dial and muscle, and these are the popular ones. So what is the problem statement? The problem statement says, given two or more sequences, find the best alignment among them. I mean, from the figure, you can see this is the best alignment you can get out of the three. Um, when we venture into the multiple sequence alignment algorithms, there are some concepts. The concepts of seeds and anchors are predominantly used in the alignment algorithms. So I thought so we should talk about the seeds. Now the seeds are, I mean, here the picture is kind of distorted, but we'll get the gist of it. Let's assume this X3 here. There is G and G are the two aligning characters here. So these we consider as seeds of length 2. And similarly again here you got AG, TAG and TAG here. This could be another seeds. So what are these are basically seeds are small regions of similarity. If the above seeds are forced to be the part of the alignment, that means we assume that these seeds have the high potential to be in the final alignment. And that's why we're calling it as heuristics. Then we can assume we can use these as anchors and try to align the regions in between those two and find the best alignment between these, the regions in between these seeds. If a seed or an anchor is of the maximal substring, and this is my research and this is our research, and we have contributed to a suite of algorithms for pairwise sequence alignment using the maximal match substring. So our idea is if we find a regions or anchors of length, of a bigger length, then we force uh, that maximal match substring to be a part of the final alignment. In that, there is an assumption, and the assumptions is that the maximum match substring, since it is the longest maximal substring, has to be part of the final alignment. So that is the assumption. Now, there are two different kinds of multiple sequence alignment algorithms. One is called the progressive, or the progressive multiple sequence alignment algorithms. So most of the multiple sequence alignment algorithms have generic steps. I'm going to explain to them. The first step is to align pairs of sequences, like I mentioned before, and to develop a scoring. Well, they're going to develop a score. So you score an alignment and put it aside. You get the score for all the sequences and create a distance score. That means how much does one sequence differ from another? And you develop a guide tree. Basically, it's a tree, like an ancestral tree, and try to build that from it's a bottom up approach in the sense that you try to align two and try to get the leaf nodes and try to branch yourself up and eventually find the roots. So when you reach there, you eventually find the sequences of all the sequences. So this approach has been used in cluster W, cluster omega, maft, and many other ones here, as you see on the screen. So one of the other things is the K-align. It's a K-align, which stands K meaning the K-mer. So it is a progressive method. The algorithm follows the same steps as the ones that I mentioned before. A guide tree is then built. So how does it differ is that it uses something called Wu-Manber approximate string matching algorithm. So it's a string matching in the sense that when you create a guide tree, there is matching, a string matching algorithm which is used to create the scoring metrics, and also creates a distance calculation. So bear in mind, when you're trying to build a tree, there are different approaches. And one of the approaches that this algorithm uses is the Umer-Mamber approximate string matching algorithms. And it also uses a dynamic programming stage at the later stages of the pairwise alignment algorithm. In this, it is trying to use this mainly to increase its sensitivity of the algorithms. So although the dynamic programming could be slow, it wants to increase its correctness or sensitivity. So that is K-line. So there is another one which is called tea coffee. A tea coffee differs from progressive in the sense it's an iterative. Like the name says, iterative. It's going to realign multiple times. So as you can see here, it receives both local and global sequence alignments in the first stage. See here, so see. Then there is a weighted signal addition. So a matrix is then built to produce a guide tree using the same method as we mentioned before. The tree is then used to segregate closely related sequences from the distantly related ones. So that is what we call the extensions. To align groups of realigned sequences, that means the sequences which are now closely related, the algorithms again uses the scores and uses an extended library. The use of dynamic programming comes at the very last stages.
Sorry for interruption, Bharat. I think 12 minutes are already over.
Okay,
So just
I'll
two
be
more minutes to bind up the presentation.
sure. So math is another algorithm. This is a very fast algorithm. And then there is another algorithm based on hidden Markov method. So eventually we come to we are now at a stage where we're using genetic algorithms. In this approach, sequences are divided and then solved separately using a guide tree. So, um, uh, so, so all the multiple sequence elements have a base case database on which they all use. So there are base case sequences, and based on these sequences, they're evaluated. So that
Người đi kèm anh chở nào được hai đứa được. Chở qua ngã tư nguy hiểm lắm.
So the future work is to use.
Yes, go on.
Yeah, so the future work is to parallelize and have a different approach than what we just mentioned here. And we'll be starting our first algorithms and multiple sequence alignment very soon. So thank you for giving me an opportunity here. I really appreciate that. And if you have any questions, let me know.
Okay, do we have any questions for him? Did you do any experiment?
We have not done any experiments as of now. Like I said, we are just starting with the sequence, multiple sequence element surveys right now.
In building the trees, okay, that's fine. In building the trees, do you consider the depths that might, for instance, if you start from the leaf,
Yes.
go into the root, do you consider the depths?
The depths are already calculated based on the scoring metrics.
Pardon
Yes.
me? Okay.
Yes.
Because you have to take cognizance of the number of children, otherwise the depth of inheritance of a tree.
Yes, that is automatically calculated based on the scoring metrics and the edit distance. Yes.
And that is going to affect the way you are going to evaluate the algorithm. Because
almost all the algorithms will be affected by that. Yes.
Okay.
Yeah. The idea of a scoring metric.
Yeah, Bharat.
Any more questions? Okay, it seems there's no other question.
I think Bharat, you wanted to say something.
No,
Okay.
I said I wanted to say that the scoring metrics and the edit distance eventually will build and bubble up the sequencing, like he was saying. So yeah. So I wanted to say that. Yeah, thank
Okay.
you, guys.
Okay. Thank you.
Thank you. One will be interested in your experiment when you do an experiment.
Yes,
and you
yes,
consider
it's
all
coming,
these
it's coming, it's coming,
Okay.
it's coming. Thank you.
All right. Okay, thank you.
Thank you.
We go to the next presenter. Mythical or realistic implementation of AI-powered driverless cars in Africa. A review of challenges and risks. Chukunonso Nwokoye. Can you make your presentation? Go ahead.
I think Professor Uki, the person is not here in this session as of now. So I think we should move ahead to the next presenter. Is any author of this paper here in this current session?
Okay, if he's not there, can we go to the next person?
Yeah.
Yeah. Mitro is there. Can you make your presentation?
Yes. Can you hear me?
All right. Yeah.
Okay. Hello, everyone. I'm Nikos Mitros from Greece. Let me share my screen. Okay. Can you see me? Can you see my screen?
Yes, we can.
Okay, nice.
Yes.
So I will make a short presentation about smart IoT sensors that is developed to monitor the cultural heritage monuments and buildings. And these sensors were developed as part of the Hyperion EU project. Okay, yes. Okay, no. Yes, sorry for that. The main problem and the reason that these sensors were developed are that the fact that the cultural heritage sites and monuments and generally historical buildings are continuously degraded throughout the years. And the main reason for that are harsh weather conditions and phenomena, such as heat waves, acid rain, floods, blizzards, and much more. Many of them are related to the climate change. And this not only causes a problem to the buildings, the cultural buildings, but also it can impact the economies and societies in general in the historical areas around them. The examples are many. A few of them are depicted here. As we can see, the degradation of the material of each building are quite visible. Of course, we cannot stop the nature and this phenomena, but we can monitor them and try to do the best to protect these monuments. So the proposed solution is IoT sensors that will be deployed on the cultural heritage and will be able to monitor the environmental condition near the area of the installation. We call it smart tags, and we have to mention here that smart tags are a fundamental part of a bigger process, that the main aims are to gather all the microclimate measurements in the cultural sites, quantify the impact and the risk for these cultural heritage sites, and the effects on the historical areas around them. And of course, based on them and the model, we will be produced and will be able to find some mitigation actions. The smart tags are described here and are quite relatively small, the size of a palm. They are unattended. They are plug and play and can be just installed and power on. They are wireless because they use the Wi-Fi to send, communicate and send the data. They have quite a long life because of the rechargeable battery, solar panel, and it has also the possibility, the capability to power them via a power source cable. And as I mentioned, they will be installed in the monuments. So the main functionalities are that they take measurements of temperature, humidity, the dew point that define the microclimate near the vicinity of the walls that they are installed. If they can define if the surface of the installation are dry or wet, which is quite important to assess the degradation of its material. The measurements can be stored in the flash memory of the device, and formatting and forwarding to the web and to the server via MQTT protocol. They support text processing capabilities, give more information to the middleware, and assess if something wrong with the measurements. There has a capability of low power mode. Particularly, the device can be set up to deep sleep mode, in which it consumes only about microampere, about some microamperes. And the power management capability that we mentioned before with the solar panel and the rechargeable battery. Here is presented the main process flow of the device during the day. First, we have the main microcontroller unit and sensor in initialization, and the communication established between them. Then we take the measurements. They are stored in the flash memory, which it can store up about 4 megabytes. This happens every 30 minutes, and we check every 24 hours if they have passed the 24 hours time limit. If not, then it goes to a low power mode for 30 minutes and take again the measurements. If 24 hours have passed, then connection to the Wi-Fi and the middleware is implemented, and all the data stored are published in a JSON format, and the process will repeat again. Here I presented the system architecture and the basic components of the device. We have as a microcontroller unit the ESP32, as a sensor for the temperature and relative humidity, a precise Sensirion CHTC3 sensor, which has also low power mode. For the dew sensor, resistive analog sensors of Samyang. Based on them, we can calculate the dry or wet state. And the power management unit, which is a TP4056 solar charger. It has protection for the battery, for the overcharge, a Lion-Ithon battery, and solar panel. And as access point and the middleware node, we use a Raspberry Pi Zero. Here is an example of the hardware assembly, the wire implementation, and the schematic. Here we can see all the components of each sensor. Okay, we say some things about the case. The case was implemented via 3D printing. It's quite relatively small, as we can see in the schematic. It is ABS the filament, IP46 rating, which is waterproof and can withstand some measure weather conditions. Designed to host all the appropriate components and the solar panel in one compact design. The color is white to have less heat absorption as possible. There are some small openings on the front and on the sides of the case to allow the air circulation and take more reliable measurements as far, especially for the humidity. And the installation is, of course, non-intrusive because it will be installed in the control sites. It can be done via adhesive tapes. Finally, we implemented a visualization platform in which we can present all the data that are taken from the network of the sensors. It was developed in a web browser-based Node-RED platform with use nodes and code blocks instead of programming code in lines, which is quite less complexity. We have MQTT input node that takes all data and the measurements from the sensors, a JSON parser node, the main process node, and the output nodes for the presented of the dashboard. Here is an example of the dashboard and the measurements of one of the devices. You see the temperature, the humidity, the dew point, and temperature humidity charts, which is presented the measurements over the time. So the conclusions are that the deterioration of the cultural heritage sites and monuments are quite a significant problem, and we must take into consideration. These problems are quite affected by the environmental conditions that are around these monuments. And of course, there is a need to process, to monitor all the climate conditions around, or most of them around them, and process this information and create a model that can quantify their impacts on them and the risk that they can produce. So for that reason and for the monitor part, we proposed the smart tags. They are capable of monitoring reliable some microclimate measurements and parameters. They use quite reliable and precise sensors and to achieve that. And also we implemented the visualization platform, which is quite easily deployed and is proposed to just presentate all the measurements that are required. So thank you all for that, for your time. If you have any questions, I will try to answer.
Well, thank you very much. Do we have any questions for him? From anybody? Okay, let me ask, has it been deployed yet?
On the cultural sites, not yet, but we have deployed in general buildings and take some measurements that I showed before, like here, but not on official monuments. This will be done near the summer, about 2 months from now. It will be deployed in Greece, in Venice, in Norway, in some of the sites.
Okay, so it's not yet deployed to be able to how do you intend to evaluate these systems after it's been deployed on the monument site? Do you have any plans on subsequent evaluation of what is taking place?
Yes, we will provide with data of official weather, let me say, sites of each country, and of course, there will be professional weather stations near the site. So we will evaluate them with the data that are required from them.
Yes, I am saying part of your deployment is that you have a program of evaluating the system because you've not deployed it. So you can say this system is going to be evaluated, say after 2 years, after 3 years, and so on and so forth, as part of your deployment program. Then another question for you is in collecting the data for the IoT devices? Do they send the measurements in real time to some other device, or you have to go there to get the readings?
No, they send it to a middleware, which is then publish all the data in the cloud, in the server that we have. We don't have to go to there and take. No, they're IoT, so they send all the measurement directly to the middleware and to the cloud, to a server.
Okay, so all those you have to take into consideration while having a program of how it will be continuously evaluated to know how it's behaving and what needs to be done.
Yes, the evaluation is in process.
You also need to be sure that your intention for deploying this system is being achieved. That can only be ascertained with actual program of evaluation on how it's going to be monitored. Okay.
Yes.
Thank you for the presentation.
Thank you too. Okay, I stop sharing now.
So we go to the next presenter. Yep. Next presenter, who is available?
Hello, I am available. Shordhavana Jakash.
Yeah.
Okay. Can you go ahead and make your presentation?
Yes.
Diagnosis of early stage lung cancer and tumor using the 5G band microstripe patched antenna. Okay, go on.
Is my screen is visible?
Yes.
Okay.
Yes.
Can I start?
Yes.
Hello everyone. Welcome to our paper presentation titled Diagnosis of Early Stage Lung Cancer and Tumor using the 5G band microstrip patch antenna. Our paper ID is 145. Myself, Shordhavana Jakash, and I'll be the presenter of this paper. And our co-authors are there in this screen. And we are from the Department of Electrical and Electronic Engineering from the American International University, Bangladesh, which is located in Dhaka, Bangladesh. So moving to the next slide, it's a table of contents. This is the table of contents. First, I'll be talking about the research goals, then introduction, then the reason of using microstrip patch antenna, then the impact of research in our society, then the block diagram, and then design and simulation, output results, comparative study, future application, and conclusion, and the references part. Moving to the next slide, which is research goal. Our research aimed to design a microstrip patch antenna in the CST software to diagnose lung cancer and tumor, capable of microbe imaging and create a lung phantom in CST with cancer and tumor cells. So our research next target is to apply the antenna on the lung phantom for reducing the antenna's performances. Moreover, to obtain a balanced radiation, to maintain the health issues of people and get a higher value of return loss, thus the antenna can accept the more radio frequency energy. So next slide, which is introduction part. So in recent decades, lung cancer and tumor has become one of the leading causes of death for people worldwide. Lung cancer and tumor remains the most lethal and the high priority cancer and the tumor. So according to the statistics of the World Health Organization, 7.6 million people died from the lung cancer and tumor every year. So among the recently invented technique for early lung cancer and tumor diagnosis, microwave imaging is the most efficient technique because a small range of power and frequency signals are used in the microwave imaging system to collect the precise result about the lung tissues. Moving to the next slide, which is why microstrip patch antenna. Antenna operates at microwave frequencies where traditional antennas are not feasible to be designed. This particular antenna type is a smaller size with a lightweight. As a result, it can be easily implantable on the human body. So these antennas have lower fabrication cost because they are easily etched on any PCB and will also provide easy access for troubleshooting during this design and development. Moving to the next slide, impact of the system on society. So by using the microwave imaging technique with microstrip patch antenna, and lung cancer and tumor can be diagnosed in a better way compared to some previous methods. So since microstrip patch antennas are cheaper, societies poor people will be beneficial. So and as well it will be useful in developing or underdeveloped countries. So next slide please. Um, it's block diagram of the design. So this is the block diagram of our design. First, we have to select the applications, and over here, our application is the lung cancer and tumor diagnosis. So we have selected microstrip patch internet. Then we have done a thorough literature review regarding this all concept. So in this paper, we selected a frequency 2.3 gigahertz and a substrate material known as FR4 lossy. Then we made different types of calculation based on the formulas and determines the dimension of our antenna. So after that, we implanted the antenna and created the lung phantom in the simulation software CST and analysis performance after applying the antenna to the phantom. So in the end, we compared our result with previous works so that we have done before. So next slide is basic questions. So these are the basics that we have used in our paper for determining the dimensions of our patch antenna. So over here, you can see that we have chosen the wide of the patch, also the effective dielectric constant, the effective length, the actual length of the patch, and the wide of the feed line. So next slide is design and simulations. So in this research work, we designed a microstrip patch antenna with an operating frequency 2.3 GHz by using the following parameters. The parameters are given on the screen. You can see over here, all the parameters are given along with its dimension that we have used. So next slide is here on the left, you can see the simulated antenna's geometry. On the right, you can see the 3D model of simulated antenna. So in the left figure, WG represent the width of the ground plane and the LG represent the length of the ground plane. W represent the width of the patch and the L represent the length of the patch. So WF represent the width of the feed line and the FI you can see in the screen represent the feed line insertion. So next slide is uh, now on the left, figure 3 represent the different parts of the created lung phantom, and on the right side you can see table 2 represent dielectric properties and their values of the lung. Next slide is after creating the cancer and the tumor affected lung model in CST, the designed free-space antenna was applied to the phantom at an operating frequency of 2.3 gigahertz. So basically, 4, 5, 6 figure shows the side view of the lung phantom after applying the antenna, then front and side view of the tumor affected lung phantom after applying the antenna, and the location of the tumor after applying the antenna in tumor affected lung phantom. Next slide is figure 7, which is represent the return loss of the antenna in tumor affected, and the figure 8 illustrate the return loss of the antenna with return loss after applying the antenna in the tumor-free lung phantom. So a return loss of minus 47.3 dB has been successfully obtained in tumor-affected lung phantom model, and a return loss of minus 49.77 dB has been received in the tumor-free lung phantom. So next slide is figure 9. Figure 9 represent the BSWR after applying the antenna in the tumor affected lung phantom, and the figure 10 also represent the BSWR after applying the antenna in the tumor free lung phantom. So the result a BSWR of 1.008466 was obtained by applying the antenna in tumor affected lung phantom, and result a BSWR of 1.007175 was obtained in the tumor-free lung phantom, which is also visible in the screen. So the next slide is figure 11, which represent the radiational efficiency after applying the antenna in the tumor-affected lung phantom. And the figure 12 represent the radiation efficiency after applying the antenna in the tumor-free lung phantom. So a radiational efficiency of 16.43 dB and minus 16.44 dB are successfully received or achieved both in the tumor-affected lung phantom and in the tumor-free lung phantom respectively. Figure 13 in the next slide shows the 3D radiational pattern, which is directivity in the cancer-affected lung model, in which a directivity value 7.42 dBi has been successfully achieved. So figure 14 also represents the 3D radiational pattern, which is gained after applying the antenna in the tumor affected lung phantom, in which a directivity value of -8.7 to 7 dBA has been successfully achieved. Next slide is a figure 15, represent the far field radiation in the tumor affected lung phantom, polar form. A lung phantom polar form fixed 90 degree, which from it there the main lobe magnitude of 7.42 dBi and the side lobe level of -4.7 dB has been achieved. The 16 number 16 figure represent the ACR calculation of 1 gram tissue. So it can be seen that the maximum value of ACR for 1 gram of tissue of is 0.127 and so the next slide is a comparative study. There are various antennas parameters such as the return loss, directivity, tumor size of the lung phantom of many previous research papers were analyzed and compared. So here you can see that our S11 value has the highest value of -47.30 dB compared to the other past work. Next slide is a future application. A substrate material and substrate thickness of the antenna can be changed in the future for better performances. So return loss can be made higher by changing the design parameters and so that the antenna will be more useful for lung cancer and tumor diagnosis. Moreover, directivity can be increased by changing patch radius and ground plane radius. Finally, different feeding techniques can be used with varying shapes for better output performances. So next slide is a conclusion part. So a rectangular microstrip patch antenna was designed successfully to diagnose lung cancer and tumor at an early stage with an operating frequency of 2.3 gigahertz. A human lung phantom was designed and a low size of tumor of 5 millimeter was placed on that phantom. So a good value of return loss and the directivity were achieved after applying the antenna on the tumor affected lung phantom. So overall, a better output parameter has been optimized compared to some previous research. So next part is references. These are the references that we have used in our research. So this is all of you. Thank you. Thank you of you.
Okay, thank you. Thank you.
Thanks.
Do we have any questions from the floor?
Sir, I have a question, sir.
Okay, do ask your question.
Okay, so I have a question for the presenter. So first
Okay,
of all, I'd like to thank you, Mr. Shohardhu Banerjee Akash, for your presentation, which is very wonderful.
yes,
I have a small question for you. That is,
yes, yes,
in
yes,
this particular research work, you have
yes,
done the analysis on the early stage of lung cancer and tumor using the
yes,
5G band microstrip patch antenna.
yes.
So what is the advantage of your design model that you have designed in this research work?
Last part, can you repeat, sir?
Okay, so my question is, in
Uh,
this research work, you have done the analysis on the early stage lung cancer and tumor
yes,
using the
yes, yes,
5G band microstrip patch antenna.
yes,
So
sure.
what is the advantage of your design model in
Yes.
this research work?
Okay, thank you, Mr. Fardin Mabu, for this question. So, from the table for comparative study, you can see that we have achieved a good value of return losses with a small size of tumor, and as a result, you can see more power will be delivered to the antenna, and the antenna will achieve more radio frequency energy, and it's give better performances for lung cancer diagnosis. So you can find it for this comparative study, so you can see clearly. So this is the answer. I think you can find it.
On that table, which is your comparison, where are you
Yes,
comparing with? Which
sir.
research are you comparing with?
Yes, sir. So we have compared some previous research paper with our proposed antenna. So you can see the return loss is the maximum of our research proposed, which is -47.30 dB, and other past work,
Is that,
which is
is that your, the first one is yours?
no, it's a last proposed antenna
Is it
last.
there?
This, yes, sir, yes, sir.
Okay, you are using the references.
Yes, sir. Yes, sir.
It's
And
okay.
the
I can.
others are past research work that we have compared it.
It would have been good if the comparison is such that you have a table that you have your own your own result and then the result from this other research work, and instead of the references. How many people read the references before comparing?
Sir, can you repeat it again?
If you can make these comparisons very clear, one column will be your result, the other one will be result from the other research sources, and so on and so forth. Because
Okay,
here
sir.
you are just giving out the references. You go to reference 1, go to reference 3, go to reference 4, 5, 10, and so on. Maybe you look at the way you do your comparison very well.
Sir, it's a number of these things we have
I know,
used in here. Yes, sir.
I know, but that's not sufficient for a comparison, except
Okay.
if in the main paper you have really compared and then you are showing us the results.
Yes, sir.
So another thing I would like you to take care of is where you have the impact of the research on the society. I suggest you use the significance because you are talking in terms of the benefit.
Yes, sir.
Is that
Hello.
correct? There's a slide where you are talking of the impact. It's not the impact per se, it's the significance. What's the significance of this research?
Sir,
How is it going to benefit? Yeah, you can use the significance, not the impact.
sir, the significance of our research is that it its more power will be delivered to the antenna, and sir, the
Yeah,
antenna
that's
will
what I'm saying. Instead of saying the impact, you use
yes,
the
sir.
word the
Okay, sir.
significance.
Okay, sir.
Yeah. Then another thing is that because this is more of a critical system where it involves life and so on and so forth. I think you need more rigorous justification of your basic equations. Were those equations yours or you got them from previous research?
Sir, hello.
The basic equations used for these
Yes, sir.
computations or measurements, did you get them from previous research or they are from your work?
Sir, this is from
Yes,
book, sir.
from your research work or from
Sir,
previous research.
sir, from literature review, sir. This basic
Okay.
questions.
Yeah, if it is from literature review and it's a standard in your paper, you need
And
to
our
cite the
experience.
sources. You need to cite the sources so that you don't claim credit for what is not yours. Do you understand?
Yes, sir.
There is need to cite the sources of these models because they belong to somebody else. And to be
Yes, sir.
sure that these models are rigorously
Sir, yes, sir.
justified.
We have cited in our paper, sir.
Okay. So those are my remarks because you need such things for this kind of work like this.
Yes, sir.
I was going to ask you one question, but you already answered it, whether you
Yes,
were aware of any previous study in this
yes,
kind of research efforts, and you have shown that, but you need to make appropriate comparisons, not just by referencing the papers, so that
yes,
we can see it very clearly.
yes, sir.
Okay, that's a nice presentation. Good luck.
Thank you, sir. Mr. Seth, sir.
Okay.
Okay.
So we go to the next presenter. Are you available? Yes, if you are
Yes,
available, you can.
yeah, yes, sir. Yes, sir, I'm available. Yes, sir, I'm here. Here to.
Accuracy of diabetes patients determination, predictions made from sugar levels using machine learning. All right.
You have 12 minutes for a presentation.
Yes. So I'm Sanjit. I'm from Sri Lanka. Thank you for this opportunity to participate in the fifth international conference, Smart Trends and Computer and Networks. Yes, I'm here to present accuracy of diabetes patients determination, prediction made from sugar levels using machine learning. Our presentation covers the following contents: introduction, related works, methodology, results, discussion, conclusion, reference as well. Yes, diabetes is on the pinnacle of global as it is started on the IDF Diabetes Atlas 2017. According to the report of IDF, 450 million of people in the world are affected by diabetes. Uh, diabetes are further 1 in 12 are attacked by disease in Southeast Asia region, and the diabetes prevents in Sri Lanka was reported at 10.7 percentage at 2019. Diabetes happen when the glucose blood level increases. By nature, there is a chemical hormone known as insulin secreted by pancreases. It helps glucose to get into the body cells and used for metabolism by acting as a key to unlock the body cell. But the diabetic occurred when this normal procedure doesn't work, when the body cell become resistant to insulin, or by not making the proper amount of insulin by pancreases. So this allows the glucose to stay in blood streams. This led to the condition of diabetes. So there are two types of diabetes, as type 1 and type 2, and in addition to it, there is a gestational diabetes that only affect the pregnant ladies, where the type 1 affected anyone when the pancreas does not produce enough insulin, but the type 2 affect the persons with the age above 40. So when it is failing to respond to the insulin, there are some factors uh, affecting diabetes as well: age and lifestyle, family history, blood sugar levels, and high blood pressure, pregnancy as well. Our study focuses on prediction of diabetes patient with the help of clinical records using data mining techniques, especially by analyzing the two sugar levels. Uh, since the data mining is currently used in different fields such as food service, telecommunication, medical care, economic, network monitoring, sports, and students performance analysis as well. Especially in medical cares, it is used in pattern finding, the prediction of patient and disease. Uh, our study focus on prediction of diabetes patients with the help of clinical record using type 2 diabetes. So next we are going to look related works. Many researchers have done their research related to the data mining in medical care, and many fields the data mining has been done with the Vega tool by analyzing several classifiers like decision tree, some uh, Navi base, and a chosen best classifier by having the highest accuracy. Some research have tuned their data set to achieve the maximum accuracy. Um, Under the methodology, so now take a look data set. We have collected the data set from Gaggle database containing the medical records of 1,000 patients. So it's include there are 11 attributes. It includes these attributes as well. Uh, and The feature selection was done using the ranker method by ranking the attributes by the individual evaluation and priority. Now, associate rule mining, uh, a priori algorithm was used to extract the best rule with the selected features. There are some values which are taken into consideration when selecting best rules. Especially like the confidence value is B high. Take a look at the classification. This was done by selecting three popular classifiers used in the data mining related researches: Navy Bayes, decision tree, and random forest. The performance matrix of each classifier was measured by the factors of MCC and F measure and T rate, TP rate and TN rate, ROC area, PRC area, and, prediction and recall. After the methodology, according to the feature selection uh, ranker method, the highest ranked two attributes were selected, that is PPBS and FBS. So PPBS mean FBS mean fast blood sugar, and PPBS mean post uh, prandial blood sugar. The glucose level, FBS is the glucose level measured after a long time of fasting. So that's mean FBS. And PPBS, the glucose level measured the particular hours after the meal, and diabetic conditions. Like and that this graph shows the relationship between FBS and PPBS in creating diabetes. So finally, so according to the selected features, the best rule was found out with highest confidence value of 0.85 in relation with FPS and PPBS using the appropriate algorithm. In associate rule mining, the extension of rule with the 0.85 confidence value, uh, it vividly show diabetes can be predicted uh, predicted using the two selected features. Then according to the performance matrix, it is found the accuracy of the uh, Navy base out performance to other with 74.8 percentage. As a discussion part, the patient prediction can be performed only examining the FBS and PPBS results, and BMI value and the genetic factors are showing less impact, and the accuracy of classification was observed to be 74.8 percentage with Navy based with FBS and PPBS. Conclusion. And we conclude, since this is a binary classification, we could get the maximum accuracy on Navy base, and we could increase the accuracy if we have a huge data set, and with that uh, these are our reference which we took for our uh, research topic. So that's it. Thank you so much for listening my presentation. If you have any question, please ask.
Okay, thank you very much. Any questions for him from the floor? Why did you choose, how did you select the machine learning algorithms used in this study? Because there are several machine learning algorithms. You have chosen J48, you have chosen naive Bayes, and one other one.
Yeah, according to the literature review, we have studied, we have learned from the related literature works. So it shows it totally outperforms with the other classifiers, especially the
Okay.
naive Bayes. It performs the binary classification with the highest accuracy. So we have chosen these three classification algorithms for the
Okay.
betterment of this research.
Okay, based on your literature research.
Yes, sir.
Because you are looking for a prediction model
Okay.
to predict that to predict diabetic patients. Can you complete that for me? You are looking for a prediction model to do exactly what?
Sorry, sir.
You are doing a prediction model
Okay.
for diabetic patients detection.
Yeah, sir.
Okay. And according to the literature, J48, naive Bayes, and the other three algorithms are the ones mostly used
Yes,
for
sir.
as classifiers.
Yeah, sir. Especially for the binary classification.
Okay, because there are several classifiers
Yeah,
that
sir.
can be used. But if from your literature search in this direction, you find that these three are the most used, then it's okay. Otherwise, it's wise also to try the other classifiers and
Yeah. Okay.
see what results you will get.
Yes, sir.
There are several other classifiers.
Okay.
Um, has this study been sold to the public in Sri Lanka, especially to government? Are they aware of it?
No, sir. We have just collected the data set from the Gaggle database. It is a database with 11 attributes consisting the common database, common data set. So this is not a regional wise or a country wise data set. So we have got from a common database. That's what we have done using that data set. Yes, sir.
Okay.
Okay, sir.
Well, that's good. Except if any person has any other thing to add. Otherwise, thank you for the presentation.
Thank you very much, sir, for listening and giving me an opportunity to present our research here. Thank you very much.
Okay. Yeah. So we have come to the end of this session. I think the other presenter is not yet around as well. Is he going to come?
I'll just announce the paper name. I think the mythical or realistic implementation of AI-powered driverless cars in Africa: review challenges and risk. The person has not presented the paper, so is he here or is she here still?
Okay.
No worries. So I think, Dr. Uki, we should close this session, session number 1A. And I appreciate your time and gesture to be a part of SmartCom 2021 and sparing your valuable time. We thank you for that. And I would like my team to showcase a certificate of appreciation to you. In the meanwhile,
Okay.
I'll just put some notes to the authors that we have sent your paper for publication now. This is for you, Dr. Oki. Thank you very much.
Thank you. Thank
We'll
you.
receive it through mail very soon.
Okay. Thank you.
And
Yeah.
the instructions for the authors that we have already submitted the data to Springer, and it will take approximately 5 months of time to get it finally published. And in the meanwhile, whatever updates we have, we will be one by one sharing it with you when and as needed. Till that time, please be patient, and we look forward to your support and your enthusiastic approach towards research and next future initiatives as well. And thank you very much. And before we close this session, I'll ask everyone to just put on their camera so that we can have a snap. So I just request everyone to put on their cameras so that we can have a snap. I think, yeah. I think many of them are not here, but anyways, whoever is here and wishes to open up the camera, please do so.
Okay.
Okay, thank you very much. I think Harsh, you have
Thank
taken
you.
the pics.
Okay.
Yeah. Perfect. Perfect.
All right.
Thank you. Thank you very
Thank you.
much,
Thank you
everyone.
so
Thank
much.
you.
And
Yeah.
still for
Thank you.
next
See
5
you.
minutes, this session is open. Before we move on to session number 2A at 4:45 p.m. So session is
Okay.
still open, and we will once close the session, and we will again relog in everyone for the session number 2A. So thank you very much, and if you have any queries, please feel free to write to me. There might be delay in
Okay.
response, but I'll respond you very soon. Thank you.
All right. Thank
Thank you,
you.
Dr. Uki. Thank you.
Thank you. Thank you. Thank you. Yeah.